I've already gone ahead and created a brand new R project in RStudio. Only have two folders this time, data and R. I have one week4.r file, which is in the R folder, and I've already downloaded the week4.dat file, which is not a format that we have talked about explicitly. And in this case, doesn't really mean anything. So we're going to go ahead and write a comment that says RStudio API code. That's nice and easy. RStudio API code. And comment 2 through 3, write code to set the working directory to the directory where your R script is saved. Easy enough. We need the RStudio API library. And then we need to set the working directory to the directory name of the active document, the path variable specifically. Oh, I didn't say that right, did I? Document, oh, active context. Oops, there we go. So set working directory, directory name, get active document context, $store path. You might have also, if you're just copy pasting code, written in RStudio API : but you don't actually have to do that. We go to next, it says nothing for line 4. Line 5, write a comment that says data import. Line 6, import functions from the package that will give access to all core tidy packages. What library is that? TidyVerse. If you use the wrong one, what would have happened? Anybody try to load TidyR or Reader instead? If you tried to do that first, you would have found you didn't have access to some of the functions. So the whole idea here, the reason I specifically said that is because if you did, for example, load Reader instead of TidyVerse, then you would have been able to use read underscore whatever. You would have been able to do the imports, but you would not have been able to do some of the later functions. So very important to recognize TidyVerse here. Also useful to start interpreting what comes down here, by the way. So this indicates ggplot2, Tibble, Tidier, Reader, Pur, and dplyr were all loaded. It also shows this guy. We're going to need to start paying more and more attention to that. What conflicts means is that there has been a library imported that has a function that already exists in your workspace. So that could be in base R, it could be in another package, you don't necessarily know. But it will tell you what is actually doing the conflicting right here, and that's why it's important to read it. So you'll notice that in dplyr and in stats, and a little more on stats in a minute, you're seeing a conflict with filter, and with dplyr and stats, you're seeing a conflict with lag. That is extremely important, because that means if you call filter, it could be from either of these two locations. And filter is a dplyr function that you will be using soon. Next week. So it's important to recognize when potential conflicts occur. Can you guess how you choose which filter you use? If I needed to use filter from the stats package or filter from dplyr, how might I do it? Yeah.
You do like we did with RStudio API.
Yep. If you explicitly want to call up dplyr's version of filter, then you would do it like that. Okay? If you just type filter, it will do whatever the default is, and you don't necessarily know what the default is unless you type it out there and recognize where it is. In this case, you can actually see that the dplyr one is the one that is by default filter, but that's not always true. So since I loaded it last, it gains precedence, but it's not always true. Also means that if I needed to use stats filter, if I needed to use the other filter function, I would have to call it explicitly. Does that make sense to everybody? Always think about the namespace that you're working in, the namespace being where is sort of the boundary conditions of the functions you're talking about, and make sure that the thing you're referring to is in the namespace you think it is. Yeah? I didn't press enter. Yes. So I did it up here in the code that you had before. If you just use the name of the function and 2 colons, or the name of the library and 2 colons, then that's how you specify it. And again, you can always tell, because if you type the name of a function that exists, it will tell you the namespace that you're in. So, not with those though. If I do filter, I get namespace filter. If I do dplyr filter, I get namespace dplyr. If I do stats filter, then I get namespace stats. Okay? So generally speaking, whatever you load last is the dominant namespace. That's the thing to remember here. Okay. Yeah, okay. Line 7. Import week 4 data file as a data frame called week4 underscore df. So we're going to use week4 underscore df gets, but now what's next? What did you do, I hope, before you typed any more at this point? There we go. We're going to look at the data file. So if we click on it, we can open a DAT file in RStudio. You could open it in a plain text editor like Notepad, Metapad, etc. also, but this is just fine. What did you look for in this file, and how did that inform what specific command you used? Yes, patterns and not called separators, though. Delimiters, very important word. Yes, so we're looking for delimiters between data, and we're also looking for other patterns in the data set. So this is kind of a weird pattern. What is the delimiter in this data set? A dash, a hyphen. So we have 1 dash 1 dash. Now we have a letter, and it's surrounded by quotes. So it looks like character strings are indicated by. Back when I was in school, they called those foxies. So this is surrounded by quotation marks by foxies. Then we have what looks like a date, also seems to be a character. In some cases, dates are a little weird. So in some data files, you might have letters surrounded by quotes, and you won't have dates surrounded by quotes. And then we got this weird thing going on over here. What does this imply? If I just import this as a hyphen delimited text file, what will happen to this set? Right now, it's surrounded by quotes. So this is a character, this is a string, just the same as this date and just the same as this guy. As far as the data file is concerned, these are identical. They are 3 character strings in a row, or 3 strings in a row. Okay? So that's important to note. So if I hadn't told you later, as I gave you a lot of context clues here, if I hadn't told you to import this as QS and I hadn't told you to later split this out into separate variables, you would have had to figure that out on your own. Sometimes the output, data file output coming from certain sources is really weird, especially if if you do anything involving biometrics, if you use any devices that pull back like heart rate data, that kind of thing. Their data formats can be really strange sometimes. So be real cautious when you look at a file to figure out exactly what's coming back. And remember that you should always take an approach of multiple data imports. Try importing it the way that you think makes sense based on looking at the file. Check it, look at the data frame, see if it worked, and try again. In some of your early projects, I noticed there's a bit of a pattern. There were mistakes that I saw that you would not have made if you had looked. So if you had actually just checked the output, the variable that you created, and you looked at it, or you checked its class, or you checked other information about it, you'd have been like, oh, right, that's not right. But instead, you just kept going. Don't do that. Code one line at a time. Do not write a program and then just run it and see if it worked. Write one line at a time, test it, refine it, write the next line, test, refine, next line, test, refine, through the whole process. So that's what we have. It looks like if we import this correctly, because again, remember that import functions can only pay attention to delimiters, and there's nested delimiters here. So we could deal with that in an import function if we were really clever about it, but it would cause a few other problems later, which I'll talk about in a second. Instead, if we import this as a hyphen delimited text file, we should end up with 1, 2, 3, 4, 5 columns. So good start. So let's try that. What function might we use for this within the TidyVerse, since I believe that was a requirement? Yes. Use a function from the library you just imported. So that's an important piece of this. So it has to be a TidyVerse function. What TidyVerse function did you use? Read dlim. You're not saying the whole thing, though. Thank you. Read underscore dlim. If you use read.dlim, it is not a TidyVerse function. RStudio helpfully notes that it's in the utils package, which is a default package in R. So if you use the wrong one, then that's not quite right. Read underscore dlim is in reader, which is part of TidyVerse. So great. We might at this point check how does read dlim work in case we've forgotten. When we go down here, we get a read underscore CSV, read underscore TSV, read underscore dlim. our usage, we get all sorts of information. Here's our standard format. What might we do first before we deal with this in too much detail? The first thing that you might want to do is do the simplest possible version of this function you can. So in that case, we're going to go one directory up. We're going to go into, I'm making sure I saved it there. Make sure that one directory up and get the week4.dat file. And we also know ahead of time that our separator is a hyphen. So that is done with the second term, which is delim. And you could have gone down here and read single character used to separate fields within a record. So we're going to do quote, hyphen, and just see what it does. Lots of weird things going on, so we should figure out why that's happening. If we look at our file up here, you can see, oh, that's not right, very clearly. It looks like that we have data appearing as our variable names. So that's a problem to solve. Otherwise, however, the data looks not terrible. We have a character vector. We have 5 like we expected. We have integer, integer, character, character, character. So we're most of the way there. But that's the kind of, detective work that's very important here. What additional parameter do I need to fix that problem? Yes. Call underscore names gets, and what does call names take? Vector, which we can define with C. And we were asked in here to use these names, casenum, parnum, stimver, and datadate. Casenum, parnum, stimver, datadate. And we're told over here, however, name the last column QS. So we'll put that there. And then we will rerun this revised function. No errors, no warnings, and now we have a data set. And the data set looks like what we think it does. We could also double check this using the next thing, which is display a summary of your data frame the tidy way. What function is that? Glimpse. We run glimpse, we get our summary. It looks just like we expect. 5 variables, 400 observations, integer, integer, 3 character vectors, and the kind of data that we were expecting. So it seems to be working. At this point, if you had other requirements, you might revise your import statement. You might add other lines to do additional formatting, which is what we end up doing here. We still have to deal with this weird character vector in QS, so that becomes the next step. Again, really important that you think about the process here versus the specific commands being used. Because when you work with your own data files, you're going to encounter a lot of weird formats. So you need to pay attention to the kind of decisions we're making and why, less so than the specific functions we are running. Okay. So, at this stage, line 9. Split QS into 5 variables. The 5 variables, they should be according to tidy philosophy. Ensure you use correct variable names. Do not change classes. Ensure the variables do not contain unnecessary white space. That is an important caveat here, because there are a couple different ways you could have done this, and some of them would not have given you the right answer. So, what do we do? Ready to type. Separate. Mm-hmm. Q1, Q2. So you did it this way. Mm-hmm. Space dash space. There you go. That worked. We're going to talk about a couple different ways you could do it, though. If you did not put spaces in your sep, what happens? Anybody do it that way? Doesn't want to admit it? Oh, we have to re-import the data file. If you did not put the space in your sep command, then you end up with this weird pattern. The 1 space, 2 space, 3 space, and then space 2 space, space 2 space, etc. And then the last one, which you're going to see for Q5, space 4, space 2, space 2, space 2. Why does that happen? Yeah. Yes. Remember, a space is literally a character that R has to deal with. It's only a space empty. It's only empty space in your head. R treats a space as a thing. It is a character. So in this case, these vectors are 1 space hyphen space 2 space hyphen space 2 space hyphen space 3 space hyphen space 4. So when you separate by hyphen, all of those spaces get pulled into. The less efficient way to do that, which still would have worked, would be to use trimws or to use str_trim, which you also learned about, to trim the white space after the fact, but that would have probably required an extra line, so you couldn't do that. So in this case, using the individual hyphens is the correct approach. Now, having said that, I don't like that. This is correct, but that is not real programmery. Why is that not programmery? Remember, a lot of this is about mindset, not just about the technical part. Why don't I like that? It's repetitive. It also requires typing each individual one. What's an alternative way to do this? So Q1 colon Q5 seems intuitive, doesn't it? That's the problem. When you type it like this, you're using what you would call quasi-notation. And what the TidyVerse does is it assumes, oh, you mean the variable called Q1. So then what it does literally is tries to figure out, well, look in week 4 underscore df, or actually look in this, for Q1. It doesn't find it, and it gives up. So you can't use quasi-notation in the into because these variables don't exist yet. If they already existed, you could, but they don't. Let's pay careful attention to what this was before. I want to decompose this. What is this? This phrase right here. What does this do? Let's play with it a little bit. I'll re-ask based on that information. What is this? A character vector. That means you need a character vector. If we go and look at separate, you will see here also names of new variables to create as character vector. So that's why you can't use quasi-notation in this particular location, because it's not expecting variable names, or it's not expecting actual variables as they exist in the R namespace. They are expecting a character vector. That means you need to create a character vector. Now, in DataCamp, we only covered a function that creates repetitive character vectors one time, and you probably don't remember it. Yep, that's why that was not required. This is a function, actually Andrew knows it, this is a function called paste. What paste does is it takes multiple character vectors, it smooshes them together into individual pieces. So if I do, for example, paste Q and 1, I end up with a Q space 1. And if I do Q1 sep equals nothing, I end up with a Q1. I can dynamically create vectors this way if I give it vector input. Say, for example, that. So this is a programmatic way to do it. And it's also a way better way to do it, because what happens when you need to do this and you have 150 variables you need to name? Are you going to literally write out 150 names of variables in this statement? I hope you are not. I hope you do that. Yeah?
In data camp, they use paste 0.
Yeah. Paste and paste 0 are very similar. So if we look in the documentation, as we always should, you will see that the difference between paste and paste 0, actually there's a couple differences, right here. Paste 0 is equivalent to paste with sep equals nothing. So yeah, same basic thing I just did. But that's really the only functional difference. If we go here and do paste 0, delete this, we end up with the same thing. How do I take advantage of that here?
Replace the C vector with paste.
And now we have exactly the same outcome. And now we can't see it. Well, I'm going to get rid of that because we don't need it. All right, so if I re-import, so we have the raw data file again, we're back to our Q1-2-3, and we run with our new command, we end up with this. In the interest of streamlined code, what else can we do? If we look at the documentation for separate, you will notice that data call into sep is the default order, so we actually don't even need these. Re-import, retest, still works. So I have just dramatically streamlined that original statement that had extra parameter specifications, it had an explicit character vector defined into a very succinct piece of code. That kind of refining is really important, because identifying those patterns, this is an idea called abstraction. Identifying patterns and writing new functions or new approaches to do those things as a pattern, as a set, rather than doing just the single purpose thing that you needed, is a way to create reusable code. Because now, having written this, having thought through how to do this, you can use the same approach in all sorts of data sets, whereas in the old approach with a single character vector defined there, you would have to rewrite that character vector every time. So think through that. Every time that you see a pattern, think about, well, wait a minute, how can I make this more succinct? In this case, it's pretty easy. It's literally one command with two parameters. In some cases, it's not. And we will get to a point where abstraction takes way longer and is not at all worth it in comparison to just doing it this straightforward, easy way. But for now, it is. Yeah?
Is there an equivalent of paste to other like types, like for numbers or something to that extent?
So it depends on what you're trying to do. So for numbers, we've already gone over a bunch. So we've looked at rep, we've looked at seq to create vector sequences, right? So if I use sequence 152, for example, it counts 1 to 5 by 2s. So that's the sort of the equivalent way. If you need to create a vector of numbers, you probably want seq or you want rep. So if we did rep 1, 5, then I get 5 1s. Usually some combination of rep and sequence will end up getting you whatever vector you want. Yeah. So paste is really going to be most useful for text, and you're probably still using sequences. Like 1:5 really is actually sequence 1 through 5. Like they're the same. So you're usually using, even when you're constructing strings, you're usually creating numeric sequences as parameters for the string construction function. Okay. It's a lot of discussion of that, which is good. It's going to get more fun in a minute, though. All right. Line 10. Coerce all 5 of your new variables into a more appropriate class using sapply. Sapply, again, is simple apply. It is the simple version of list apply, lapply, which in turn is a list version of apply. So remember how all those are related. So sapply is simple apply. What does sapply do? Remember that the lapply family takes a list, iterates over each item of the list, and applies a function with the first parameter equal to the item in the list. Then returns a list based on that input. sapply then says, can I simplify that list into a different class, usually a vector or matrix? Okay. So sapply takes a list and it returns a list or vector or matrix depending on whatever it can simplify down to. And if you were concerned in your code about it returning a single specific class, what would you use instead? Remember? vapply. Yes. Okay. So we're going to use sapply. Coerce all 5 of your new variables into a more appropriate class. Well, what class are they? We can check that very easily in RStudio by looking at the environment. We can also use glimpse. Right now, we're getting 5 character vectors back. But those don't look like character vectors. Why did this happen? When you use separate, it splits a character vector into character vectors. I'll tell you a secret about that in a minute, too. It would have made your life a lot easier if I told you about it. But right now, it separates character vectors into other character vectors. So these are not already numbers. These are not numbers as far as R is concerned. If you try to add these two together, like if I tried to add Q1 and Q2 together, what would happen? Would it work? I see a few of you having a wrong answer. There you go. Non-numeric assignment's a binary operator in this case, although I'm just adding 2 list items together. So let's do as character. That was. And let's try as numeric. So because they're the wrong class, we're not going to be able to do certain things that we might want to do later if we wanted to manipulate those variables. I will tell you, however, if you were using dplyr, dplyr would coerce that automatically later using some of the functions you'll learn next week. But that's not good practice. You should always coerce variables to the correct type before you start working, because it does cause weird issues. Remember what happened when we tried to convert an empty string into an integer. What does it return? NA, which is not what you necessarily expect. So coercing it ahead of time is a good way to make it behave the way you think it's going to behave. So that's what we do. So how do I set up this function? Coerce 5 variables using apply. Well, what does coerce mean in this context? What function am I probably going to use? So if we need to use as integer or as numeric, either one, we need to figure out a function, a way to use lapply or sapply that will apply to each of those 5 variables the function as.numeric or as.integer. So how do I write that? Week4 underscore df. Gets.
Oh, well, I had next to week4 df, I had bracket, comma, 5 through 9.
There we go. 5 through 9.
Excuse me, gets sapply. Week4 underscore df. Bracket 5 through 9. Comma as numeric.
Did that work? It did. So having tested this, there we go. So key to understanding how this worked, and again, this is week4 underscore df bracket 5 through 9 gets sapply week4 df bracket 5 through 9 as numeric. To understand how this works, you have to remember how apply works and how variable assignment to multiple variables works. So, what does this actually mean? Week 4 underscore df bracket 5 colon 9. What does that mean? I'll go even simpler. What does bracket mean? Subset. So take week 4 underscore df and subset by. And what does 5 colon 9 mean in this context? It is columns, but not exactly columns. It ends up being interpreted as columns, but what is it as written? List items. Remember? When you don't put a comma in there, it interprets it as list items. So this is look at list items 5 colon 9 in week 4 underscore df, because a data frame is a list that acts like a matrix. Remember that piece, okay? So in reality, a data frame is a list. And in this case, it's a list of 9 different variables. So here we're saying, look at list items 5 through 9 in week underscore .df. Take each of those individually, so each of those individual variables, and apply as numeric such that each of those list items is the first function, the first parameter of as.numeric. That's what's happening. Okay? So when we run this, it's actually running a series of commands as.numeric week 4 underscore df 5. That's the first thing it does. Just that one list item, and it gets that out, and it adds it back into a piece of output. What happens if I just run the sapply part of this? I'll give you another clue. It's returning a matrix of type double. Why is it doing that? What does sapply do? Simplifies. It always tries to get rid of lists if it can. If it looks like something that could be expressed as not a list, it will coerce it down to not a list. Would this function have worked with lapply? Did you try it? It did exactly the same thing. Why? If I go down here and change these two statements, we'll do type first. Why does it work either way? If I use sapply, it returns a matrix of type double. If I use lapply, it returns a list, which does not by default have a type, so it just still calls it a list. Because again, remember, a list is a combination of any number of different types. This is where, again, R is kind of weird. A data frame is a list that acts like a matrix. So you can give it a matrix or a list as long as the list looks like a data frame, and it will still work. So these statements are identical. lapply goes over each list item here, week 4 underscore df 5 through 9. It applies as.numeric to each element of that list. And you can see that occurring in the same way if we do it one at a time. We can't do as numeric. As numeric, we'd have to convert it to as matrix? Oh, well, maybe that would work. That's actually a good question. Yep. So when it runs this function, in order to run as numeric, it has to down convert it to a matrix, work on it, and then return it back in the same original format. Yeah. That's an excellent question. That also works. Why does it work? Because this is already a list that acts like a matrix. So if you call it as 5:9, it says, subset list. Then when it tries to run lapply, it says, wait a minute, as numeric won't work on lists, so we will down-convert it, or not down-convert it, we'll coerce it into a matrix and then run this function. Then because we have lapply, instead of returning it as a matrix, we'll return it as a list. In sapply, we do the opposite. We say, well, wait a minute, a matrix works, so let's not return a list. And in this context, instead of subsetting items 5 through 9, you're explicitly telling it, well, wait a minute, treat this as a matrix and look at columns 5 through 9 instead of list items 5 through 9. They all do the same thing, but they do them slightly different ways. In a different context, that could cause problems. If you need this to return a list, if you need it to return something else, if this function expects a matrix, or if this function expects a list, then those differences can matter. And that statement can fail in certain circumstances if you don't pay attention to that. Right now, it's easy. Right now, you don't have weird type conversion problems that you experience with real data. So it works for now, but you need to understand why it works and what exactly is happening under the hood. The reason we can assign it back like this is because week4_df subsetted by items 5 through 9, well, that just means that it expects a 5-column list or a 5-item list that meets the requirements of a data frame or a 5-column matrix. And if either of those is true, then this get statement will work just fine. So again, R does a lot of that under the hood stuff for you to make it a little easier. But at the same time, if you're not paying attention, it can be a problem in some contexts. So be really careful. Always decompose every statement. Why does it work the way that it works? And then do what I was just doing. Pull out the individual pieces, change a little thing, and see what's different. Check the class, check the type, make sure that it works the way you think it works. Even now, I've been using this for years, I still do this the entire time I'm coding. Because what you really don't want to happen is to have do a conversion somewhere in your program for it to look like it seems to have worked, to get 20 lines later and then discover, wait a minute, something's wrong, and I don't know where it's happening. And then you have to debug the entire program line by line to figure out where the error is coming from. That's what you don't want to happen. So make sure that these things are doing what you think they're doing and why they're doing it. Okay. 11. This is a fun one. Lines 11 through 15 convert all values of 0 within these 5 variables only into missing values. Extra credit if you can do it in one line. Who did it in one line? Okay, a little less than half. Okay. The 5-line version's fairly easy. What is that? And the reason it's fairly easy because there was literally an example of this in DataCamp. If you went to the right slide, you could have basically copy-pasted it. What comes after week4_df? We're going to take the list item and we're going to subset by all cases where week4_df question 1 is equal to 0. And for all of those, we're going to assign NA. And I bet you can guess then how we do the rest of them. Oh, wait, I missed a piece. Q1, Q2. And the reason you have to do this is why we just saw that error. Q4 and Q5. There we go. That is the most straightforward way to do this. But, again, that should raise your programmer hackles, your developing programmer hackles. You'll feel them later. That should raise your hackles because we have now 5 repeats of essentially the same statement. That works. That is totally functional. And we can actually go and check it. If we open week4_df and start sorting by things and then look at the end, we can find the NAs that have appeared as a result of that. So it does work, but not very efficiently. And the additional problem with that is, again, if we had 150 variables, and if you're working with Qualtrics, this will happen a lot. If you're working with 150 variables, and you want to replace everything that's actually missing with an NA instead of the default missing character, then you're going to want to do this for all those variables simultaneously, not with individual characters. So this is correct, but not what I would do. There are a couple of different ways to do it. Among those that did this as one command, what did you do? Or what function did you use? So you did week 4, 5 to 9.
Open brackets again.
Oh, open brackets again. Okay. And then week 4. 5 to 9. Yep. Equals.
I have 0 quotes, but it needs to be, and then
So this is a subsetting approach. Let's actually recourse everything to make sure this works. We go back to week 4. Yep, I already saw some NAs. Here we go. So what we're doing in this context is we are saying week 4 DF for variables 5 to 9. Take cases where variables 5 to 9 are 0, equals 0. And if you put it in quotes, then you're defining it as a character vector, but the equality would coerce it. So it would coerce back down to the same thing. Gets NA. So that's another approach. What else? Anybody do anything else different? Yes? Well, what type of thing did you do? Well, that is a cup. Oh yeah, it would be there. Yep. There's another way. Any other ways? There's still more. I'll give you the shorter versions of both of these. We could also do this as, yeah, you get the same thing actually. You could, if you wanted to use which, you could actually do it within the context of the one above it. That would do the same thing. And if you wanted to use an anonymous function, that would be a good way to do it. Well, so yeah, okay. Actually, I'm going to do this a slightly different way, but basically what you did. Which is going to take week 4, and I would just say instead of that, replace does work, but you could also just do if x equals 0, then return NA, else return x. Yeah, that should work too. Oh, it doesn't matter. No, it does matter. Oh, because we can't use... Oh, I know why that didn't work. So I'd have to use apply, actually, instead. We haven't actually talked about apply in here, but what... missing value... Oh, because I don't have the original. Whoops. Boop, boop, and boop. All of those work. So let's step through all of them. So we have one right here. Yes, that we started with. In this case, we are taking all cases where the data frame 5 through 9 is equal to 0 and replacing them with NA and putting that back into those columns, which works fine. In this version, we are looking at this entire list, and for each item in that list, we are running an anonymous function that replaces x with values where x equals 0 with NA. It checks for the values where x is equal to 0 and replaces them with NA. And it does that one line at a time, coerces it back down to a matrix, and then returns it back here. In this function, we are, instead of directly doing the test, we're using which to create a matrix of true-false values, which then gets fed back into the specification of week 4. And in this version, I'm using apply. And apply is the base function for sapply and lapply. What apply does is you can just go by row, by column, or by row and by column. That's what actually what this specifies, this C1, comma 2. That says go by row and by column. So if that was a 1, I think, yeah, 1 it would go by row at a time, 2 goes by column at a time, and 1, comma 2 does every cell individually. So then what this does, it checks, does each cell equal 0? If it does, return an A, and otherwise return 0. And then you give all of those functions back to there. So there are at least 6 different ways that you can go about this. And I hope you're getting more reinforcement as to why this is a language. The further we get, the more different approaches will work for most things. Right now, you've only learned enough functions to do 1 or 2, or in this case, 6 different ways. But that will get even longer. There will literally be hundreds of possible ways. If I ask you, for example, in English, give me a sentence that asks another person how they're feeling. There are a lot of different ways to do that. So the same is true in programming. There are a lot of different ways to accomplish anything. But any of these would work as an extra credit opportunity. So hopefully you did one of those. We're going to skip down now since we didn't put anything for 11 through 15. Convert data date into a class appropriate for date times. Well, what is it now? It's a character vector. So what might we do to convert a character vector into an appropriate class for a date time? What appropriate class is a date time? What is better? POSIX, yes. There's also a date class, which is related to POSIX, but they're basically the same thing. So how do we do that? We have 2 lines to do it. That's interesting. So you did luberdate, and then did what? That is, I think, by a good margin, the easiest way to do this. There is a way to use really clever as.posixct or as.posixlts here, but frankly, once you have luberdate, you really shouldn't do that. Because luberdate makes things, for every normal-looking format of date, just way easier, which is why it's called luberdate. So, yeah, this format works great. Turns it into a POSIXct with the POSIX format, all in one step. We can also go back and look at the raw data frame if we want, just to make sure that everything is formatted the way we think it is, and it is. You can also very conveniently now just sort to see where this ranges. We have between December 13th, 2016, ranging to February 27th, 2017. So, a lot of dates in there. Okay, everybody with me up to this point? Great. Line 18, skip. Line 19, write data analysis. Line 20. Anyone that skipped Q2 is not usable. So the problem, if you read the prompt at the very top, is that each person in this data set is represented 4 times. So that's not good. So if anybody skipped a Q2 ever, they're not a usable case. That means that we need to identify cases in groups of 4. The easiest way to do that is to actually convert the data set into groups of 4 before you check. So that's what you're asked to do. Create a new data frame called Q2 overtime underscore df. Q2 overtime df gets. That contains each participant number on a single row with values corresponding to each version of the stimulus as columns. In other words, that is 5 total variables, participant number, and 4 conditions. So, if we need to have the individual values for each condition as each variable, and currently the data set has 4 cases per person, what function do we need? Spread from tidy. So we're going to spread. We're going to also automatically send in week 4 underscore df, but we don't really want all of week 4 underscore df, do we? What do we want? So we only want a few columns of this. How do we do that? Oh, subset. So we did subset week 4 or something? Will that work? Do it with brackets. Okay, what do we put in brackets? Oh, comma, I see. Comma, and then what? What do you want after parnum? Okay. What else do I need here? Anything else? We have 100 observations, so that looks right. We see each participant number appears only one time. All of our conditions now are labeled as columns. We can see all our NAs in there. That seemed to work. Any alternative approaches? So one of the things that you can do in TidyVerse is if you want everything except a variable, you can use a minus sign. So I don't know if that, was that a data camp? I know it's in the dplyr portion. They already covered it. So if you use I don't think there was an explicit lesson on it. I think they just used it in a couple things. Yeah. If you use a minus here, this would, for example, refer to all columns except for parnum, stimver, and Q2. So you could do it in reverse. You'd have to change that to be Q1, Q3, Q4, Q5, and case num. But yeah, that would still work. The other way, remember, you can just use column numbers. That also works. Yeah. Using the names explicitly means that if this data frame changes shape but still has the same variable names in it in the future, then yes, it will still work. Whereas the column numbers might change. So now we have Q2 over time. Excellent. Line 21. Using Q2 over time, display the proportion of usable cases out of those collected. You have to know what a proportion is to answer this question. What do you do?
All right, so open parentheses.
Okay.
N row. Open parentheses. Q2 over time df. Q2 underscore.
Over. Oh, I see. Okay.
And then go to the code right.
Yep.
Okay. Space. Minus. N row. Open parentheses. Q2 over time df. Open bracket. Is. NA. Open parentheses. Q2 over time df. Alright, outside that parentheses, a comma. And then. Okay, go the whole way to the right.
Yep.
Divided by n row of parentheses Q2 over time df.
Success. Does anybody have another way to do this? The mean of complete cases. Q2 over time df. Yep. You could have alternatively done this in a slightly longer way, which is equally correct. Instead of using mean, for example, you could have used sum and just manually divided it. You could have alternatively done this as n row. All of those do the same thing. But, yes, the key is identifying some way to identify only cases that don't have NAs in them. And complete .cases is a much easier way than doing that. You can do subsetting by is.na, but that's basically what complete cases does anyway. So that's one of the reasons why this is in TidyVerse, is just so you don't have to write that kind of code. Okay. Everybody got 91? All right. And at that point, you would submit. I'm going to leave that one. Am I 21? Yeah, we're done. All right. So did that make sense to everybody? If you missed pieces of that, does it now make sense? Okay. This, again, will get more ambiguous as we move forward. There will be many, many ways to do things, and that's why I've been emphasizing as we go to understand why the functions you're using work the way they do. Because eventually, I will just be able to say things like, eliminate all cases with missing data, and you will have to do something to make that happen in a data set that doesn't necessarily have zeros or NAs. You will just have to figure out how to get rid of them. Maybe we'll say missing data in this data set is represented by -99 for some variables and -999 for some variables. Eliminate all missing cases. Done. So you should, in your head right now, if you've been following along and understand these functions, say, oh, I could do that a couple different ways, and here's what they are. So that's where we're headed. Again, the goal here, to get you fluent, not just a survival phrase speaker. Okay? All right. For next week, those two lessons, again, the two new data camps are about dplyr. So it's not just reading and formatting data sets, but it's actually creating new variables, doing things like calculating mean scores will be part of that. How do you actually, what is the easiest way within the TidyVerse to do operations on individual variables one at a time? A large part of the TidyVerse is designed to make it so you don't have to use the apply functions. A lot of it. Because the apply functions, if you haven't noticed, are kind of weird to read. They are often strangely formatted. They are still useful, and you still need to know them because there's stuff you can't do in TidyVerse that you can do with apply. But this doesn't make for a super intuitive kind of read format. And you will find in TidyVerse that a lot of the way that Tidy is designed is specifically around the idea of creating code that literally anyone can read. So even a person that doesn't know R could come back and say, oh, I see you did this, then this, then this, then this, then this, in a way that if you're using apply and anonymous functions and all this,